Hello folks, welcome to my channel Java Demystified by SSR. Here comes the question number 28. What are inner classes in Java? Let's demystify this question. So this is the outline. We have nested classes in Java, and some of the nested classes are called inner classes. So if you see the outline, we have non-static nested classes which are also called inner classes, and we have static nested classes. And in inner classes which are non-static, there are again three kinds: member class, anonymous inner class, and local class. Let's understand all these things in detail. What are nested classes? In Java, we can actually define a class in another class, and these classes called nested classes. These classes are introduced from JDK 1.1 onward. So you have some outer class, and as part of your class you can actually define one more class. So these classes are nested classes. A class contains other class definition. A class contains other class definition inside it. Not only one class, it can have a number of classes defined inside. So those classes are called nested classes. Let's understand some terminology related to the nested classes. Basically, nested classes are divided into two categories: static nested classes. That means these nested classes are declared static. The classes with the static modifier, like class A, I will have static class A. So this is a static nested class. And we have non-static nested classes which are also called inner classes. Something like this: I have a class, let's say this is class A. Now I have static class some B, and I have class some C. Now there are two nested classes. One is a static nested class, another is inner class. A nested class is a member of its enclosing class, and inner classes which are non-static have access to other members of its enclosing class even if they are declared private. Because these classes are defined inside some other class, these nested classes can access the members of its outer class even if they are private. We know in a class we have data members, we have methods, we have constructors, and which are all having different modifiers, different visibility specifiers. Like a member, we have a nested class defined inside the class, and this particular class has access to other members of the outer class or its enclosing class, including the private members, because as long as you are within a class, private members are accessible. Now the nested class is uh, just like a member of the enclosing class. And when it comes to static nested classes, and static nested classes will not be having access to other members except static members, because non-static will not work in static context. So static nested classes can access static members of its enclosing class. And as a member of the outer class, a nested class can be declared as private, public, protected, and static as well. You know, the outer class, the modifiers which are applicable for outer class are public. So we are writing public classes, and we have unspecified classes, we have final classes, we have abstract classes. We can actually make a class as strict FP. So these 5 modifiers can be applied to an outer class. But an outer class cannot be a private class. So we cannot actually write private class A or protected class A or static class A. So these modifiers are not applicable to outer classes. But a nested class that is defined inside a class can be private, can be protected, can be static. And all other modifiers which are applicable to outer class can be applicable to nested classes as well. And why actually we require nested classes? So this is one of the important questions to understand. Because you can have n number of classes defined. We can actually create objects of those classes, and we can actually call the methods of those classes. That is always possible. And if at all we want to use another class in this particular class, I can actually create an object of that particular class in my class definition, and I can actually access all those members using the object of that particular other class. As an example, if you take a customer in a bank, customer will have customer name, customer ID, customer account number, bank balance, and so details, and he is also having some address. So this address alone can be treated as a separate class address, and address can be specified over there. And in my customer class, because I have a separate address class available, I can actually create a reference of that particular address class over here in my customer, and I can actually access that particular address details. That is possible. That is association. Customer class has an address. That is possible. Why actually we require a nested class? Why a class has to be defined inside the other class? Let's understand. There are several reasons actually. The first reason is it is a way of logically grouping classes. It's a way of logically grouping classes that are only used in one place. So whenever we are actually modeling the solution to a problem using object-oriented analysis and design, we initially identify the entities, we usually identify the classes, and we model the relationships. When we model the relationship, usually we will find the relations like this. So let me write those relations. We have association relationship, so which is actually a structural relationship. So that means there is no semantic relationship that exists between the entities. Then we actually say association. For example, customer is having some address. Address is different, customer is different, but customer contains some address actually. So this is some association, and this association is actually two kinds. One is aggregation, another is composition. So aggregation is has a relationship. Aggregation is has a relationship, has something. So customer has some address, school has departments, body and some parts. So this is has a relationship we also call whole by part relationship. And we also have a composition which is also kind of has a relationship, but here this is a stronger relationship. It also has a relationship, whereas this has a also called whole by part relationship. This is also called whole by part relationship. One will be whole and another will be part of that one, like school is the whole and department is a part, a school and teacher, college and students, whole by part relationship. and this is also whole by part relationship, but the difference is this has to be understood. Aggregation, whenever we say aggregation, this is also whole by part relationship, and if part ceases, part leaves, whole still exists. That means in a college, one student leaves, still college will be called as a college because there are other students as well. If you take a flower, flower has petals, a number of petals. One petal ceases or gone, then still it is a flower. Then it is aggregation relationship. You find when you are modeling entities of such kind, whole by part relationship, where one part ceases and still whole exists, then that is aggregation. That is the usual phenomena. College, department, school, teachers, school, students, etc. We can have a number of examples for that. Whereas composition, which is also a form of association, which is also has a relationship, but here there is a stronger bonding between the whole and part. So here what happens, if part ceases, whole does not exist. Part ceases, there is no meaning for the whole, then it is actually a composition. As an example, if you take a computer system, a computer, a computer is one entity and there is other entity called processor. If processor doesn't exist, then we cannot call that as a computer, because processor forms part of this particular computer. So now I have two entities, computer and the processor, and processor ceases, then there is no computer. So we cannot call this as a computer because it's just a bare metal, because there is no processor. So this relationship is a stronger relationship, stronger bond between the whole and part. And this has to be made as a composition relationship. And in your modeling, if you find any composite relationship and any entities you see, then those have to be made as nested classes. So your whole will be the outer class and the part will be the nested class. So that's how you actually have to make up a nested class. Otherwise there is no need, because we can actually create a number of classes, we can create objects of those classes, and we can use wherever we want. And if at all strictly you are following the design, and whenever you find the entities which are having the composite relationship, then you must have to define a part kind of class should be in the whole. So you have the outer class that is representing whole, and you have the part classes which are representing parts in the composition relationship. So that's why we have a nested classes. Okay, so of course there are some other relationships as well, like association. We have dependency relationship, we have inheritance relationship, that is generalization specialization, we have realization that happens between classes and interfaces, class and abstract classes. But when we are logically grouping the classes, on what basis we are logically grouping the classes, there should be some relationship. If you find an association and that too a composition, then the use of nested class will come over there. Okay, that's the reason for having a nested classes. And also, so there are other compelling reasons for having nested classes. Nested classes will increase encapsulation. Sure, in a class we have encapsulation, so data members and methods are tied together such that data will not move freely around the system, and data can be accessed only through the methods which we define. Now you are keeping a class inside other class, definitely encapsulation increases, because anybody want to access the nested class, one has to go through the outer class. So one level of encapsulation was there with the nested classes. And of course, nested classes can lead to more readable and maintainable code. If you have your nesting levels are at some reasonable length, then it is readable as well as maintainable. Yeah, so different types of nested classes. We understood there are static nested classes and we have non-static nested classes. Let's see here. The static nested classes, if at all they exist, they will exist as a non-local named. That means a static nested class will have a name and that is a non-local class. So a local class defined in a method, that is also possible, but static nested classes will be non-local named classes. That means they are member classes. So let me actually write that one. So yeah, so these non-local named classes are nothing but member. Just like any other member in a class, static nested classes are member classes. Okay, so then we have inner classes. So inner classes are three kinds. We have local classes. That means the inner classes can be defined as part of a method as well. Local classes. The local class is a class which is defined inside a method of the outer class. And these local class can be anonymous and named. That means a local class can have a name, that is named local class, and we have anonymous class. A local class can be there without any name, that is called anonymous inner class. And of course we have a non-local class as well, that is actually called member class. Okay, so what are the types? We have non-static classes, those are inner classes. We have member class, we have anonymous inner class, and we have a local class which is defined in a method. Anonymous class also defined within a method, but which is having no name. So anonymous inner class, a local inner class, and member inner class. When it comes to static nested classes can be just a member classes. Yeah, let's now understand a few more details. So let's now understand inner classes. So an inner class is associated with an instance of its enclosing class and has a direct access to the, outside objects, methods and fields. An inner class which is non-static is associated with the instance of its enclosing class. That means we have an outer class and you have an inner class. This inner class is associated with an instance of the outer class and it has access to all the methods and members of its enclosing class. Because inner class is associated with an instance of the outer class, it cannot define any static members. So that means an inner class cannot have any static members because inner class will be associated with instance. Whenever you are speaking of an instance, whenever you are speaking of an object, static does not exist. Static refers to class. So that's why static members or methods cannot be defined inside an inner class. That means we cannot actually have main method publish static void main return in an inner class because static doesn't applicable to inner classes. And objects that are instances of inner class exist within instance of the outer class. So when come to the object, you have an outer class and outer object. Now this inner class which is defined inside the outer class, the object of this inner class will exist inside the outer class object. The objects of inner classes will exist within instance of the outer class. So let's now understand with a pictorial representation. I have class outer class and I have some class inner class, the non-static class we can define like this. And then the object of this inner class will exist within the object of outer class. Let's understand that. So you have the object of outer class, that is instance of outer class, and you have the members which are defined over here, and it has some methods. The methods will be in the class area. Now when you create an inner class object, the inner class object is going to get created inside this particular outer object, and this instance has access to all the members of the outer object including the private members, because it is part of the outer class. Yeah. So now one thing, so how to create an object of an inner class? How to instantiate an inner class? To instantiate an inner class, one must first instantiate the outer class, because inner class objects exist within outer class objects. So in order to instantiate, one must first instantiate the outer class. Then the inner object has to be created. So what is the syntax for creation of that? So outer class dot inner object. So this is syntax for creating inner object. So inner object, how to refer inner object? Outer class dot inner class, some inner object equals to outer object dot new inner class. The new inner class, new is operator, inner class is a constructor, right? So the object, new inner class object, exists within the outer object. Let us assume you have A and B classes. A is outer class and B is the inner class. Now how do you create an instance of inner class B? So this is the syntax, right? A outer class A dot inner class B small b, this is the reference variable, equal to A dot. So what is A? A is an object of outer class A dot new B. That means new B creates an object. This object exists within the object of outer class. So this is something like this. Let me draw. So here you have the outer object first initially created. So in order to create that, what we do is simply we say A equals to a new A, and so now A will be referring to this outer object. So this outer object actually is object A, right? So now whenever you have to create inner object, it will be like this: A dot B, some B equals to A dot new B. So now we have the object that is created. So this is the inner object, and what is the name of it? The object is B. The object is B, and which is referred by small b. So now we have two references. Actually B is referred by this particular small b, and this outer object is referred by this particular small a. So this is how the objects are going to get created. In the outer object, the inner object is going to be created, and this is the syntax. Yeah, so let's proceed. So whenever we compile, actually, so whenever you have an outer class and we have defined some inner classes inside, and when you compile, so how the dot class file for the inner class is generated? Let's understand that. So compiling any class in Java produces a dot class file that we know. So a class dot name dot class. For example, I have a class A, and after compilation, I will get a dot class. Then compiling a class with one or more inner classes causes both classes to be compiled and produces two or more dot class files. That is depending on how many number of nested classes that you are writing. For example, if you have only one outer class and one nested class, then what actually happens? So class name dot class, this is for outer class, and class name dollar inner class name dot class. This is how dot class file will be generated for inner class. For example, my outer class is A and my inner class is B. Now after compiling that particular class a dot java, so then I will have a dot class and a dollar b dot class. So this is how compiler will generate dot class file for inner class. Okay, so these are the theoretical details behind the nested classes. So to sum up, before going to write the program, let me sum up actually. So there are nested classes in Java. So that means one can define a class inside other class. So the class which are defining other class is actually called a nested class. Then the enclosing class is called outer class. And these nested classes are basically two kinds. One is static nested classes, which exists as member classes. And then we have non-static classes, which are actually called inner classes. And these inner classes are three kinds. First one is member inner class, just like a member. And these inner classes can be defined within a method as well. When you define within a method of a class, those classes can be local, called as local classes, and these local classes can be named or nameless. Okay, so the nameless local classes are called anonymous inner classes. Okay, so now let's so those are the kinds. Actually later some more details, like so if at all you want to create inner object, this inner object will exist within the outer object. And whenever you compile this particular class containing nested classes, you will get outer class dot class, and the dot class file for inner class will be separated by dollar, just like outer class dollar inner class dot class. Okay, so those all things let's see with a program. So now here I have an outer class. So class outer, I just named the class name as outer. You can actually make up public, private, something like this. There is no problem. Yeah. So what are all modifiers which are possible for an outer class? It can be public, it can be final, it can be abstract, it can be strict FP, and it can be unspecified. So 5 modifiers will be applicable for outer classes. Okay. So now this outer class, public class outer class, has a member. So that is a private member. So that private member is actually a name which is of type string and which has some data called Java. Okay, so this name is Java. Now I have, if you see, class inner. So this class can be public, this class can be private, this class can be protected, and this class can also be static. Then it is a static nested class. So we don't have any private classes as outer classes or protected classes as outer classes or static, but private, protected, static can be applied to the nested classes. So here I am calling this inner class. So inner classes are non-static classes. So it can be private, protected, and public as well. So those visibilities I can specify for these classes. Yeah. So now this inner class, which is defined in the outer class, has a method. So some message method. So in the message, what it is doing is it is actually printing the name. What is name? Name is actually its enclosing class member, that is a private member. So these inner classes can access all the data members and methods of the outer class, including the private. So here I am showing an example of accessing a private member of the outer class. Okay, so this inner class has a method and I am done with my inner class. So inner class is defined and this inner class has one method, and this method behavior is actually accessing the enclosing class private member. That's it. So we are done with inner class, and this outer class also has some method called disp method. Okay, so because outer class has some members and it has inner classes and it can have some methods, it can have constructors, everything, right? So now it has some method, some disp method, and it says system.out.println I am from outer class. It just says I am from outer class. So this is a method of outer class and this is the inner class defined and this is the data member. Okay, so now done. Now done. So now what actually happens for this particular code? There is an outer class and it contains one nested class which is a non-static. That's why it is inner class, right? Yeah. So this is not executable class because I am not writing main method here. So if at all I want, I can actually write main method over there. So but what I am doing is I am actually writing the main method in another class called test. I have a class test. I have a class test, and this class test has main method. Okay, so now my source file name should be test.java because test class is executable class, right? Yeah, so now here what I'm doing is I have two behaviors. One behavior is disp method which belongs to outer, and another behavior is message which belongs to inner. So now I need to create objects of both outer and inner. Of course, I must have to create outer object, then only I can actually access inner, right? So two objects are required. So now what I'm doing, outer out equals to, so outer out, my object, which is referring to outer object is out. So that means my reference variable, which refers to the outer object, is out. Okay, so through this, so outer object is going to get created, right? Now how to create inner objects? So we have seen the syntax as well. So if at all you want to create inner objects, so this is the reference variable inner in. So outer dot inner in. So because inner doesn't exist separately, it is part of outer. So outer dot inner, and this is the reference variable, equals to, and inner objects exist in outer objects, right? So out dot new inner, out dot new inner. So what actually happens? Let me explain this. Whenever outer dot out equal to new outer happens in the heap, area, what actually happens in the heap, an object is going to get created, and which is referred by, let me actually take a stack actually, because the main stack is going to get created. So now which is actually referred by um, the variable called out. The reference variable out actually will be referring to this particular out object. Okay, so this is what actually happening for this statement. Then outer dot inner in equals to out dot new inner. So now I have one more reference variable, which is my local variable. This local variable is in, and this in actually is going to refer to the heap, but this object new inner, this new object is going to get created in the out object, right? So now I have an out object which is actually getting created in this out object, right? So now my reference actually from in to this particular inner object. So this is what actually going to happen by this. Okay, so now I say in dot message, in object has been created, right? So this is referring to inner. So inner, I have a message method. This message method is available here in my class area. I have the class area here. And how many classes have got created? So this class area for outer dot class, and I have one more class area that is available for outer dollar inner dot class. So when I compile this program, so three classes will get generated, right? Test dot class, outer dot class, outer dollar inner class. So this is inner class area, this is outer class area, and the message method is available over here. And in the outer class we have the disk method as this method, and of course in the test class we have the main method, right? So now whenever we say in dot message, the message method is available over here and it will get executed. While it is executing, it can actually access a member called name. So the name is available here in this object, name equals to Java, and it is going to get printed. So for this I will get Java. And out dot disp, so out object, and there is a disp method, and when you disp, it is going to give us I am from outer class. Okay, so this is an example explain which can actually illustrate nested classes, and specifically the inner classes. So let me save this part and let me compile that. As well. So let me save initially. I have saved this, and Java C a test dot Java, right? Because all these classes are there in test dot this one actually. So okay, so because I have two public classes, right? So in a source file, whenever you have a public class, so definitely that class should contain the main method. Okay, so I should not keep it public because I am actually making my main class also here in the same source file. Okay, so this class can be made public. Even you can omit also because it contains the main method actually. Okay, so that's why it actually compiler actually generated an error for me. Yeah, now there will be no error actually. So compiled successfully. And how many classes have got generated? How many classes have got generated? Let's see. Yeah, if you notice here, so there is a outer dot class, outer dot, outer dollar, inner dot class, and also test dot class. So three class files have got generated, and we have Java P to know the bytecodes as well, right? So if at all we want to see, you are interested in the bytecodes of Java P, outer, dollar, inner. Yeah, so compile from test.java. It is available in class outer. Okay, outer dollar inner actually is actually part of this particular outer class. So this is how the high level bytecodes. If you say -c, then you will actually get the low level bytecodes as well. Okay, so now let me run actually. So Java space test. Then we will see in dot message it prints me Java, and out dot dis prints me I am from outer class. Yeah, see Java and I am from outer class. So it's working fine, right? Yeah, so what else we can actually do is here, yeah, so I have this method in outer class. I can also have another method in my inner class, and the same this method can be there because this is a different class, right? This is a different class. So outer class is different, outer dollar inner class is also different. So outer dollar inner dot disp, outer dot disp. So these two classes have different scope resolutions. So we can actually have same disp method in inner and this disp method in outer. See, if you're writing two separate classes A and B, in A class you have a disp method, in B class also you have a disp method. There is no problem, right? The same fashion. Here outer class is different and inner class is different. So you can actually have same disp method. So now what I'm doing here in my main method, actually I'm saying in dot disp. Let's see whether it is possible or not. Yeah, compile Java C test.java. There is no problem. And when I run, you can see Java. I am from outer, and here also it's saying I'm from outer because I have not changed it. So actually it is I am from inner. So if I write I am from inner, I am going to get the same output, right? Already we have got the outputs. So for clarity, let me again compile and then run. So now you can see I am from outer class, I am from inner class, and this is Java, right? So it's working. Okay. So now we can also do so many other things as well. Yeah. So when actually I am creating an object here for this inner. So inner class has message method and which has a disp method. Now what I'm doing is in this disp method, I can do something like this. Inner in equals to new inner. I am instantiating my inner in the disp method of the outer class. And I can say in dot message because there is a message method, and I can actually call in dot disp as well. Okay, because all these things I am doing in my outer class method disp. Now here in my main method, I don't require all this stuff. Okay, so already my inner object I am instantiating in my disp method. I don't require all this stuff. What I require is just I require an outer object. Just I require an outer object. Outer object out equal to new outer. Whenever I say out dot disp, so outer object is created, and we know the rule. Before creating inner object, outer object has to be created. So outer object has been created. Then whenever we are calling out dot disp, so it goes over there, it prints some statement. Now here inner object is instantiated, and in dot message in dot disp. Okay, so this is going to get executed. There is no problem actually. So in the first case, I have instantiated in my main method. Now what I'm doing is this inner class I am instantiating as part of my uh, method of my outer class. This is also possible. Okay, so let me test this. Java C test.java. So then Java space test. Now see, I am from outer class. Now out.disp, it has got printed first. Then Java in dot message, that is Java, and I am from inner class. Okay, so both are same actually. So we are not deviating the rule. So after creating outer object only, the inner object is getting created, right? Yeah. So this is about inner classes. Okay, and then we have local classes. That means as part of this method, I can actually create one class. Okay, so this all this class definition I can write as part of this method. So simply I can copy entire this class stuff and I can put into this particular class, that is called a local class. A class can be defined in a method of a class, that is called a local class, and this class has a name, so this is a local named class. Okay, and whenever you are defining local class, local means it is actually part of some method, so we cannot actually apply modifiers to that. Visibility modifiers like public, private, protected, default cannot be applicable to there, and any other modifiers out of 12 modifiers except final modifier, a local class cannot have any other modifier. So that final is also to designate the constants. In Java, constants are represented with the final modifier. So that's why final is allowed in local class and no other visibility specifiers or modifiers are allowed. Okay, so this is about the inner classes. Hope you have understood the inner classes concept clearly, and if you like this explanation, please share this video to your friends and colleagues. Please like the video and don't forget to subscribe to my channel. Thank you. Thanks for your time.